Hello viewers, welcome to today's GATE lecture. So today we are going to see programming and data structure, and I am Priyadarshini, Assistant Professor, Department of Computer Science and Engineering in SA Engineering College. So let's get into the video. So in programming and data structure, we are just going to cover binary search tree. In this we are having programming in C, recursion, arrays, stack, queues, linked lists, trees, binary search tree, binary heap, and graph. So before getting into binary search tree, we have to know what is tree and what is the functionality of tree. So we can see about trees. A tree is a non-linear data structure used to represent hierarchical relationship. So what is a hierarchical relationship in the case? So this is an example for hierarchical relationship. Here we are having a root node and we are having some left subtrees and we are having right subtrees. So these circles are called nodes and these arrows are called edges. Okay. And terminologies of graph. Here root, that is a topmost node. This is a root here. Okay. Now the parent and a child, that is an immediate predecessor and a successor. That is also a root node. Root is also called as a parent node. Okay. Now a leaf, external node with no children. Here the last node, that is a last level, we are having no children from either right side or a left side. So this is the leaf node. Then internal nodes. Internal nodes are nothing but after a root node which has either one child or two child. Okay, so this is an internal node. Subtrees are nothing but this is a left subtree which is apart from the root, that is from the left side of the root is left subtree and right side of the root is right subtree. And what is the properties of tree? That is how you are going to check whether you are doing the binary search tree properly. That we are having only one property, that is number of edges is equal to number of nodes minus 1. So what is edges called? These arrows are called edges and nodes are these circles. So the arrows will be 1 minus from the node. So if for example if you are having a node 5 nodes and the edges will be 5 minus 1, so the edges will be 4. From this you can cross verify and check the patent. Okay. Next, binary tree. Have to know what is binary tree before getting into binary search tree. So we are just going to search something in a tree, that is binary search tree. But before getting into binary search tree, we have to know what is binary tree. Okay, a binary tree is a tree where each node has at most 2 children. So the binary tree should have at most 2 children. It can have 1 children or it should not have any children. That should not be possible. So at least it should have 1 children. So this is a root node, this is left subtrees and this is right subtree. So this is a basic structure of binary. Then what is binary search tree? A binary search tree is a binary tree where left child values are smaller and right child values are greater than the root node. So there will be a root node and from the root node the left side will always be lesser when compared to the root node. Then right side will always be greater when comparing to the root node. So that is the first property. INORDER traversal of BST gives the elements in sorted order. INORDER traversals are nothing but we are just going to traverse the binary tree. Traversals means we are just moving or visiting at least the nodes. Okay, so we have to visit each and every node at least once or else exactly once. Okay, so that is in order. We can see in next slide. Okay, so then the third point is searching and inserting elements in is fast in a BST. So using BST, searching and insertion is very fast. So that's why we are moving into binary search tree. Binary search tree operations. We are having 3 operations in binary search tree. One is searching, another one is insertion and deletion. One by one we can see in next slide. First, searching. starting from the root node. So every search or everything like inserting or deleting, whatever performance you are doing in binary search, it should start from a root. So start from the root node. Then second point, if the key is equal, search is successful. If we are just going to search some value in our binary search tree, you have to compare that value with the root node. If the root node and the value is same, then you can stop the search there itself and you can say that the value is present in this BST. Then the second value, if the key is smaller, move to the left subtree. As I have already told, root node, from the root node left side is smaller comparing to the root node and right side is greater comparing to the root node. So if the key is smaller, you have to move to the left side of the root node. Then if the key is greater, move to the right subtree. If the key is greater than the root node, you have to move to the right subtree. Okay, then you can find the values using the comparing and you can get the values. Okay. Insertion, starting from the root node. So everything will start from the root node. If the key is smaller, move to the left subtree. If the key is smaller from the root node, then you have to move from the left subtree, and if the key is greater, move to the right subtree. So these three properties will be constant for each and everything, like searching, sorting, or inserting and deleting. Okay. Then continue until an empty position is found, because you are going to insert some value into the binary search tree. So you have to find the proper and appropriate way to set this position. So you have to find the empty position and you have to insert the value in the BST. Insert the new node as a leaf node. Leaf node is nothing but the node which doesn't have any children. Okay. Then deletion, starting from the root node. So everything starts from root node. If the key is smaller, move to the left subtree. If the key is greater, move to the right subtree. So here we are having three rules to how we are going to delete a value. Okay. So the first one is, if the value that you are going to delete is present in the leaf node, you can directly remove it. Okay. You don't want to do anything extra. You can just remove it directly. Then one child, if the node is having one child and you are just going to delete that value, then that child will act as a parent. Okay, so that is a second rule. Then third is, if the node that which you are going to delete has two children, then you have to delete that value, like in order successor or predecessor. Either that may be having two children, so you can just put predecessor or a successor in the parent node. Okay, so that is deletion. Then binary tree traversal. Traversals has three types. They are in-order traversal, pre-order traversal, post-order traversal. How we are going to visit each and every node. Okay, you can visit each and every node with the three types, that is in-order, pre-order and post-order. In in-order, you will be traversing like left, root and then right. We are having a node. In that, if you are going to use in-order traversal, first you have to visit left node, then right and then root and then right. Okay. Then pre-order traversal is root, left and right. First you have to traverse the root and then left and then right. Then post-order traversal is left, right and root. First you have to move on to left and then right and then you have to move to root. One thing you have to keep in mind is in-order traversal, if you want to traverse in order, then the values, then the nodes will be in ascending order. Okay, so that will be in a sorted list. This you have to keep in mind. Binary tree traversal. I'll just give you one example for how we are just going to traverse the value in three ways. So first in order, left, root and then right. Okay, now this is a root, and from the root, left side is called left subtree and right side is called right subtree. Here, in order means left, root and then right. Okay, so first in the left side you have to move. This is the leftmost chunk, so this 4 has to be entered here. Okay, now left, root and then right, so the value will be 4, 2, 5. Then this part is over now. This is a left for this root node. So in the left we are not having anything, so we are moving to 1, that is the root. So after that 1 we are writing. Okay, now the root is also completed. Now we are moving to the right side. Here we have to check left, root and then right. So 6, 3 and then 7. So here 4, 2, 5, 1, 6, 3 and 7. So this is the in order traversal. We are just traversing from left, root and then right. After completing here we are moving to the root alone because we are not having any left subchild left. So we are just going to the root and we are just moving here. In here also we are having left, root and right. We are writing accordingly. Is that clear? So this is in order. Now next we are moving to pre-order. Okay, pre-order, root, left and right. So first you have to take the root, that is 1. Okay, then left, we are just moving to left side and here we have to see again we are having a nodes like this. Then again you have to start from the first, root, left and then right. So you have to write 2. Then left and right, so 4 and 5. So this side is over now and we are just moving to this side. Here we are coming, here we are having a root, that is 3. So 3, 6 and 7. 3, 6 and 7. So this is the pre-order. Okay, so in pre-order the root will be in front, in order root will be in middle, and in post-order the root will be in last. Okay, so from this you can keep that in mind. Root will be in the middle for in order, and the pre-order it will be in front, and post-order it will be in last. Okay, so in this way you have to calculate pre-order. Next we are moving to post-order. What is post-order? It is like a pre-order but left, right and root. We are just going to traverse in the way left, right and then root. Okay, first we are coming to left side. So 4. 4 is in the leftmost corner. So we are just writing 4. Then right. Right is 5. So 5. Then the root. Root is 2. So we are writing 2. This left side is over now. And here we are coming to the root. Okay, then here we are having left. Okay, we are not just going to take this one because 1 is the root. Root should always come at the last. That is for post order. So we are moving to this right subtree. Here 6 is the left, so we are adding 6, and right is 7. The root is 3. Okay, now the leftover is just the root, and the root will be always at the last. Root will be always at the last in post order. In pre-order the root will be in front. So from that you can easily understand and solve the gate question. So these are all the simple tricks that you have to keep in mind. So in post order the root will be always in the last value. Okay, here root will be always in the last. Then in pre-order the root will be in the first place. Post order in the case, in order you'll be having in the middle. Okay, how we are just going to find, how we know that in order just they have given a in order value. If the in order value is given, then how will you know which is the root? Okay, so in order you have to arrange the given set of nodes in an ascending order. In that way you can find that in order roots. Okay, now let's move on to next slide. I have taken one gate question. The question is the pre-ordered traversal sequence of a binary search tree is 30, 20, 10, 15, 25, 23, 39, 35 and 42. These are all the nodes they have given in the question. So which one of the following is the post-order traversal sequence of the same BST? So they have given a pre-order traversal and they have asked the post-order traversal. How will be the nodes are arranged, and they have given a 4 choices. So let's see how we are just going to solve this. First, the pre-order traversal sequence of a binary search. In pre-order, where we'll be having a root? We'll be having the root in first one. So this 30 is the root. Okay. Here. So 30 you can write here. You know that 30 is the root. So after completing the binary search tree drawing, then only we can say that when we are just going to write the post order. Okay. So post order can be found using the in order. Okay. First you have to write in order. After writing in order, you can find the post order easily. Okay. So in order will be always in an ascending order, I have said. Na? So you have to write these value in an ascending order. Okay. So in order, first value is 10, then 15, then 20, 23, 25, 30, 35, 39, 42. So this will be your in order. So here we are having a root 30. So left side of this root will all comes under left subtree. Then right of this root will come under right subtree. Okay. So let's redirect this 30 and left and right. In the left you will be having 10, 15, 20, 23 and 25. And in the right you will be having 35, 39 and 42. Here 30 we have already fixed in the root. So now next 20. Here we are having 20. So this 20 goes as a root here. And in the 20 we will be having 2 roots because 10, 15 will comes under left side. And 23, 25 comes under right side. Okay. Likewise here 35, 39 and 42 will remain like this. So 20 we have placed in a correct order. Okay. Next we have to place 10. So here we are having a 10. Now 10 will be your node and 15 will come to the right of it because 15 is greater compared to this root. So this 15 will be erased. Okay now? Likewise this 10 is placed now and 15 is placed now. After that 25. So here 25 will act as a root and 23 will be its left child. Okay. Okay. So 25 is also arranged, 23 is also arranged. Then next 39. Here 39 is here, so we have to write 39 here. And its left and right is 35 and 42. 35, 42. Then we are not having any leftover values, so this will be your in order tree. Okay, now this will be your BST. Okay, from this we can now easily find out what will be the post order traversal. So what is the rule for post order traversal? the root will be at the last. So left, right and then root. Likewise here you can see now, first we are taking this one. For 10 we are not having any left child, we are having only the right child, but the thing is left, right and then root. So left we are not having anything, so left you have to leave it as a empty. Right is 15, so your value will start from 15. So here in the question, option A we are having 10 at the first, but 2, 3, 4 we are having 15 in the first. So obviously we can see that first option is eliminated from the choices. So from these three, one will be the answer. So after this, right and then the root, next will be 10. Okay, so this one is over now. So 15, 10. 10 will be the next value. Check here. We are having 15, 10 and 15, 10 in option 2 and 4. So this 3 is eliminated now. We are having only 2 options now. That will be exactly correct. So 2 and 4. Let's get into deeper so that we can find the exact value. Okay. So this one is over now. Next again left, right and then root. This left for 20 we are not having anything. So leave this left. So right, if you are coming to the right, again we are having a left value. So 23 will be applied here. 23 left, we are not having any right value. Then we are moving to the root, that is 25. Then here we are coming. Okay. These values are over now. Okay, now we are moving to this part. For this 20, for this 30 we have to take now. This is the root, this will be the left child and this will be the right child. So then next the 20 value will be written. That is the left. And again we are coming to the right side. Here we are having under the left. So 35, right is 42 and root is 39. At the last, this is also over now. This one is also over now. So the leftover is 30, that should be placed at the last. Okay. So 15, 10, 23, 25, 20, 35, 42, 39 and 30. So fourth option is your correct option. So in this way you can easily traverse these values and you can find out this question. Okay, so from this I'll conclude that in order, pre-order and post-order is very much clear for you now. So next video we can see each and everything like heaps and graphs. Thank you for watching this video. Thank you.